Hello everyone, today I want to introduce you to arithmetic sequences. We'll have a look at what they are and also some results that make working with them a little bit easier. Okay, so let's start with the definition of what are arithmetic sequences. Well, first of all, what's a sequence? Sequence is simply a set of numbers that we've put into some order. Okay, so for example, -5, 2, 9, 0, they're just numbers that have been put in some order. In this case there, we've just got 4, so that's called a finite sequence. Or we could have an infinite sequence, for example, 1, 2, 3, 4, 5, and so on ad infinitum. Okay, so these are both just sequences. What are arithmetic sequences? Arithmetic sequences are sequences where every single number increases by a set distance from the number before it. So, for example, 1, 2, 3, 4, 5 is an example of an arithmetic sequences because at each step we're increasing exactly by 1. Similarly, we could increase maybe by 2. So 1, 3, 5, 7, and so on is also an arithmetic sequences, here with a common difference of 2 instead of 1. Okay, so we can introduce some notation to make this a bit easier. We'll call the first term of the sequence T1, and then the second T2, and so on. So we can refer to the nth term of the sequence as Tn. And then we can say, well, an arithmetic sequence is one that for any Tn plus 1, we get that term by taking the previous term, so that's Tn, and adding on some constant number d to it, okay? So, for example, in the sequence 2, 4, 6, 8, and so on, so an infinite sequence, this is arithmetic because for each t of n plus 1, we add on 2 to get to the next term. Okay, so I've just left some exercises here. Have a think. Do you think the first sequence is arithmetic? Do you think the second is arithmetic? Okay, so just have a think about that. I'll give you a second. Okay, so the first sequence in this case is arithmetic because we're increasing exactly by 3 in every step, and the second is not because we increase by 3 and then suddenly we increase by 1. So no, even if it happens at any point during the sequence, that can't be an arithmetic sequence anymore. Okay, now let's consider this problem. We know our first term is T1, and we've got a common difference of 5, d equals 5. So what happens if we want to find what the 100th term of the sequence is? Like, obviously, we can find what it is by finding T2. So T2 would be 2 plus 5, which is 7. And then finding the next one. So T3 would be 7 plus 5, which is 12. And keep doing that 100 times. But it's going to take a while and it's quite impractical. So we want to find a better way of doing this. And we're going to do this by making some quite simple observations. So first of all, we have T1 equals 2. Okay, let's find the next term. So the next term, T2, we take T1 and then we add 5 to it. Okay, but we know what T1 is. That's 2, so that's 2 plus 5. Okay, what about T3? So T3, that's just T2, and then we add 5 to that. But we know what T2 is, right? It's 2 plus 5. So now T3 is 2 plus 5 plus another 5. Okay, maybe you can see where this is going. For T4, we do the same thing again. We have, it's 2 plus 5 plus 5 plus 5. So you've got 3 5s. And yeah, you could probably see now what T5 is going to be. We're just going to add on another 5, right? We can write it out a bit nicer in this form. So we've got that first term, which is 2 at the start, and then we're adding on multiples of 5 at each step. Okay, so already for T100, we can figure out that it must be 2 plus 3 times, so 2 plus 99 times 5, right? Because you can see the multiple is always 1 less than the number term of the sequence, right? Okay, so let's summarize this for all arithmetic sequences. We can say that for any arithmetic sequence, we can get Tn not in terms of just the previous term, because that's quite impractical. We have to find all of the terms before that. We can get it just in terms of n. Okay, so give me an n, and I'll tell you what the nth term is. Okay, and presuming we know what T1 is and we know what the common difference D is. Okay, so that's one nice result. Now we know if we have some information about the arithmetic sequence, we can find any term of the sequence. Yeah, so T100 we can do in that way. So 297. Now I want to talk about arithmetic series. Okay, so a series is basically like a sequence, but now we're going to sum up the terms. Okay, so in this example, and we're going to use this as to work through in a similar way to get to a nice result. If we want to add up all of the numbers up to 100. Okay, so a series is just a sum of a sequence, and in much the same way, an arithmetic series is the sum of an arithmetic sequence. Makes sense. Okay, so how are we going to solve to evaluate the sum? Well, it's just a finite sum. Okay, so we can, move things around. That's completely okay. And so I'm going to group the 1 and the 100 together. Okay, so that's 101. Then I'm going to take the 2 and the 99. Okay, so I'm going from each side, and that's also 101. Okay, and so you see I'm grouping them together so that each one of these pairs sums up to 101. Okay, why do we want to do that? Well, now we've just got 101 plus 101, and it's exactly, we've got 50 of them, right? Because we've gone from 1 up to 50. And so we can just multiply through, okay? So it's 50 times 101, which is a very easy multiplication. We get 5,050, okay? So we can actually do this for any arithmetic series, okay? Now we just have to think, how can we express it in more general terms? Well, one, the number that we're going to multiply through, so the number that the pairs are going to add to, in this case 101, we get that by taking the first term of the sequence and by taking the last term of the sequence. Okay, so 1 plus 100, that's our first and last terms. Okay, and then what number do we multiply that by? And here it's 50. Well, that's just going to be half of the number of terms that we have. Okay, so it's the number of terms times divided by 2. Okay, and so let's express this in general terms. If we call the sum of the first n terms Sn, we know that we've got that number that the pairs add to. So 101 is what we had before. That's T1 plus Tn, first and last term. Okay, and we're going to multiply that by half the amount of terms, so n divided by 2. Okay, but we have found a formula for Tn, right? That was our previous result. We said that Tn is the first term plus n minus 1d. So we can put that into the equation and you get sort of an alternative form. We can simplify down a little bit. It's an alternative form of that first formula. Okay, so the way I'm going to present this result is just having both of them there. Sometimes we may want to look at the first result. Maybe we know what the first and last terms are, so we just add them up and use that formula. Or sometimes maybe we don't, so we can use the second. Okay, they're just two alternative forms for the same thing, the sum of the first n terms of an arithmetic sequence. Okay, so that's all. Thank you very much for listening. I'll see you in the next topic.